Good evening, Doctor. This is my presentation about the explainable cloud forensics of virtual machines in heterogeneous distributed data centers. That's the content. This slide shows the basic statistics of the cloud computing market and how it has been growing, and the stakeholders that provide the cloud computing service to the population. It is seen that Amazon Web Services is the largest cloud services contributor to the population. So this slide here shows the cloud computing, the data center growth, the cloud data center growth, how it is growing, and the amount of money it contributes. For example, in terms of the data center cloud market, the growth in terms of cloud data center market. For example, in 2024, it was at 26.6 billion US dollars. It is anticipated that it will achieve 69.45 billion US dollars in 2033. So it also shows how the cloud incidents that have manifested, for example, ransomware at 28%. This is the graph that shows the presentations of the previous slides. So this is the cloud data center market size or growth. As you can see, it is growing gradually. And then this one shows the security incidents registered as of 2024 and phishing attacks dominating. And this one shows Amazon Web Services. This is the background. So this slide here shows, it's a research paper which I read. It shows how the traditional methods such as signature-based detection failing to detect the threats and having a problem of being unable to detect threats or new or unknown threats. So there was a problem of these traditional methods of not being in a position to detect the new threats because they are built on predefined set of known threats with a high false positive rate within the cloud networks and social media platforms. So even there's a problem of explainability, lacking explainability. That will help in building a trustworthy system, detection system. Problem statement. It is a challenge to detect crime-related data from the virtual machines that are spread across multiple geographical jurisdictions and locations. It's not easy. The ground forensics team, it's not easy to traverse from one center to another physically. There's also a problem of the traditional methods, forensics methods, such as the other ones, the one which I've mentioned in the previous slide, they struggle. They struggle at detecting new threats. And also they are slow and tedious. They are so tedious in detecting crime-related evidence from the virtual machines. Then also there's also a problem of the complex nature of the cloud computing platform, consisting of all those attributes. For example, the various layers of virtualization. The objective: to develop a deep learning network framework that can be used by forensics investigators to detect crime-related activities from the virtual machines spread across heterogeneous data centers with the help of explainable AI. Those are some of the objectives. For example, identify, detect the virtual machine instances, the status, identify the feature importance, train and build deep learning models, evaluate the deep learning models, and also implement explainable AI. Significance. Um, um, so the implemented system will bypass the dynamic cloud computing environment with virtual machines that will help to detect anomalies with a high true positive rate for the VM instances deployed in the cloud in various heterogeneous data centers. So it also help to alert stakeholders and mitigate or identify or investigate both insider and outsider threats. So it also help institutions or CSPs to build strong security systems and defense mechanisms to block such similar incidents. It also helps the cloud forensics team or the CSPs or other stakeholders to know how these models are coming up with their predictions by explaining their black box nature, and also help to generate comprehensive reports that can be used by these teams, since they have known how the deep learning models are coming up with their predictions. Now, this is a research paper that used a number of deep learning models and machine learning solutions. This is also another paper that used the CNN convolutional neural network that performed the best on non-virtualized networks and performed poorly on virtualized networks because of the encapsulation protocols. For example, the virtual extensible local area network across 50 epochs. So this is also another the paper. It combined what we call improved goal and improved CNN to detect anomalies in the cloud, such as denials of service. It is built on 5 classifiers, on 5 classes. Sorry, 5 classes. So this one used what we call internal external introspection system that leveraged both virtual machine introspection and MFA with machine learning. It is built on 6 classifiers. It also performed well in detecting benign and malicious activities within the data generated by by MFA, memory forensics analysis. This research paper is just explain the processes, methods, tools, and approaches that are used by digital forensics analysts. Approaches of digital forensics in the cloud and social media platforms. It shows the processes, challenges, and the forensics methods. This is the dataset description, how data was generated. This is a proposed framework. So this is data pre-processing, how data is going to be pre-processed. For example, we shall have to impute or fill out missing values or the null values. We shall also use the we shall also use the CMOD to balance the target variable. We shall also do some data transformations. Okay, we shall remove irrelevant data. So that will optimize the performance of this model. Then we shall perform also what we call an EDA on the data set. These are the models that we shall build. This is the architecture of the deep learning models. For example, an LSTM will be built on 2 layers. The first layer will be having 50 neurons, and the first layer 50 neurons, second layer 1 neuron with a sigmoid activation function. Model training, we shall divide the dataset into two, that is 80% training and 20% testing. And then we shall feed this training data into these 4 models. And then we shall train using back and forward propagation. Propagation, feed forward pass, and back propagation across 50 epochs. Then we shall apply explainable AI using Lyman Sharp. And then I will test the model evaluation. We shall test the model on the 20% data. And then we shall have to use these matrices of precision we call accuracy F1 score. I'll also construct AUC ORC curve and also construct a coherent matrix. Yes, these are the specific objects and their mappings. For example, one of the objectives is to implement XAI, and I'll have one of the methods to instantiating Lyman Sharp explainers. Sorry, and also construct visualizations for explanations, such as waterfall plots, local and global interpretation plots, and then Lime local feature importance graphs. That's the references, work plan. Yes, thanks, Doctor. That's my presentation. Thank you so much.